So as promised, folks, a solution to 2 and to 3. We already saw the solution to 1. So let's talk about this. So first thing I want to do is draw myself a little picture, right? And so here's where she starts, and she's running around there. And here we go. So actually, oddly enough, you know, if this is Scarsdale and I'm looking at this top down, you know, well, we'll just call this north, east, west, south. We won't get too much into the actual geography there. So what do I know? I know that the distance for one lap is equal to the distance for the second lap, is equal to the distance for the third lap, is equal to the distance for the fourth lap, and that's all 400 meters. I would just call this time 1, this time 2, this time 3, and this time 4. Okay, here's the thing. If you think about it though, what is her displacement for one lap? Her displacement during each lap is going to be 0. So if I wanted to write down those knowns, I would be writing down like delta S1 is 0, delta S2 is 0, delta S3 is 0, delta S4 is 0, delta S5 is 0. But I'm going to show you a slight shortcut we can take here, and we can take the shortcut because it's definitionally true and there's no math involved. But let's just stick with what we have. The total distance here is equal to the sum of the distances always, right? I didn't write them down in terms of displacements because the information is not presented in terms of displacements. And therefore, there's no standard for writing them if the information is not presented that way. So there we go. Total distance is 1,600 meters. And then for part B, what's your total displacement? I would say delta ST is equal to 0 meters. And the rationale is very simply because her final and initial positions are identical. That's all. I don't have to do any more work because that's definitely true. There's no math involved to prove that, but I needed to state the fact that allowed this to be true. Okay? And then C, I want to know the average speed, so I'm going to go, whoops, running out of ink on that one. I'm going to say speed average is total distance over total time. And then I get my 1,600 meters over a total time. Oh man, so probably what I should do is a little bit of side work here. Total time is time 1 plus time 2 plus time 3 plus time 4. Since we have an equation for everything we do, 62.2 seconds plus 57.6 seconds, because this is an actual calculation, 61.3 seconds plus 64.7 seconds. And then we can figure out what that total amount of time is. Just have to forgive me, folks, as I grab my calculator so that I can do the work we need. Okay, should have grabbed that before I started making the video, but I did not. So, okay, 61.3 plus 64.7, and we get 245.8 seconds, and we can throw that in our calculators then in order to calculate what our average speed is. So 1,600 divided by 245.8 seconds gives us 6.51 meters per second. And then if I go to do average velocity, total displacement over total time, and that's just equal to 0 over 245.8 seconds, or 0 meters per second, and there we go. Okay? And so that is what we have to show for number 2. Awesome. Let's look at number 3. So we're revisiting the first problem, but this time Jim walks northeast, then west, then south. Oh man. So here's the thing, from what notation Kean gave us, in that original problem was all delta y's, but here we have mixes of delta y's and delta x's. Now, I think it is a bad idea if we're mixing delta y's and delta x's sometimes to name things delta y and delta x. You can, but we have to just be very careful with it. So I'm going to show two ways of doing it depending on the way you name it. So let's say I name everything in terms of s's or delta s's. So north, south, west, and east. Let's keep with Eve's declaration of south as positive, but why don't we make west positive as well, right? Oh my God, Descartes would be having a cow, right? So let's say delta S1 is 600 meters north, delta S2 is 200 meters east, delta S3 is 300 meters west, delta S4 is 800 meters south. T total is still 12 minutes. But now, if I want to do this, which of our answers would be different and which were the same? Well, if you notice, the distances walked are all the same. And so the answer here is D total would be the same because the path length is the same. And if the total distance and the total time is the same, the average speed is the same. So I'm not going to recalculate that. So what I need to recalculate now are what are the total displacements as well as what is the final velocity. Let's actually draw a quick picture here. So Jim walks north, east, then west, then south. So he's going to end up somewhere down there. And this is my resultant. But now I'm not going to label it R. I'm going to label it with its correct title, delta ST. So that is the resultant displacement. Or, as we're just going to call it, the total displacement. We called things by the resultant when we didn't have better vocabulary because we were talking about abstract quantities and not specific to the physics. So how would I do this? Well, it's the same exact process by which we did before, right? In this case, it makes sense to make my chart. X and Y, boom. And so I go delta S, okay, so that has 0 in the X, negative 600 in the Y. This has negative 200 meters in the X, 0 in the Y. This has positive 300 meters in the X, 0 in the Y. This is 0 in the X, and positive 800 meters in the Y. And therefore, my X component here is plus 100 meters, and my Y component is plus 200 meters. That plus sign, because it's X, that means west, and that means south. That means that my final vector is south of west. Oh my God, it totally is. So nice. So delta ST there is equal to, really what this is, if you think about it, is the total X displacement squared plus the total Y displacement squared, right? And so plugging that in, I get 100 meters quantity squared plus 200 meters quantity squared. And when I do the sum of the square roots of those, let's do that. So that is going to be that. Oh, geez, sorry. I have a weird logic calculator that I'm working with here. Okay. We should get a result of 223.6 meters. Now, am I done? No, I'm not, because if you notice here, I need to know what that angle is, the reference angle. So the reference angle that delta ST makes is going to be the inverse tangent of the Y part total over the X part total. So now the inverse tangent of 200 meters over 100 meters, or the inverse tangent of 2. So here we go, inverse tangent of 2. And oh, this thing is in radian mode. Let's turn that into degree mode. Inverse tangent of 2, and I'm getting 63.4 degrees. Therefore, my final answer is the total displacement is 223.6 meters at 63.4 degrees south of west. Boom. It's the vector problem that we did before. There's all the work that I need to do. I showed a sketch. I did this. I didn't have to do it to scale. I made my table, and there you go. Now, let's say that we did this, but instead of labeling things delta S's, we did like Kian did, and we just used delta Y's and delta X's to specify the information. I would have delta Y1 is equal to 600 meters north, but delta Y2 would be this 800 meters south. And then separately, I would have delta X1 is 200 meters east, and delta X2 is 300 meters west. And then I would find delta Y total, because that would be delta Y1 plus delta Y2, and then delta X total, which would be delta X1 plus delta X2, like separate equations. And then once I had delta X total and delta Y total, the process picks up exactly here, and you would get the exact same results. The notation tells you exactly what to do. We can't mix X things with Y things when we're talking about things in vector quantities. So there you go. Use that as a model for how to do your homework.